Okay, so for this question, you have a variable over a variable, so we need to use the quotient rule. When we take the derivative of the bottom, we just get 1. When we take the derivative of the top, the 10 is going to tag along. Now, if this was natural log of t, we would just have the argument in the denominator. So we would have t, and then we would multiply in the numerator by the derivative of the argument, and that would just give us 1. Now, of course, this isn't natural log. This is log base 4. So we have to adjust it and write natural log of 4 in the denominator. So plugging this into the quotient rule, we'll start with the bottom. So g prime of t will look like top times the derivative, or bottom, excuse me, which is our t, times the derivative of the top, so 10, and then over t natural log of 4, minus, and then the 10 log base 4 of t times 1, all over the bottom squared t squared. Now, to simplify this, of course, it's pretty obvious that these t's are going to cancel out. And then we look at this numerator part and it's like, okay, I got to get a common denominator of some sort. But the reality is there is a common denominator already present, because this log base 4 of t, if you remember back to your pre-calculus days, there was this change of base formula. And that change of base formula meant that you had like log of some base bm was going to equal the natural log of m over the natural log of the base. So in this particular instance, if I use that change of base formula on this log base 4 of t, that's going to give me minus 10 natural log of t over the natural log of 4. And then in that rewriting, we now have a common denominator of natural log of 4. That is then all over t squared, which again we can assume to be over 1. And once we assume that it's over 1, we'll just want to multiply by the reciprocal of that denominator. So that gives us 10 minus 10 natural log of t over the natural log of 4 times 1 over t squared. Now, if you look at further simplifying this, 10 is obviously a common denominator, or a GCF, 1 minus the natural log of t over, and then here is the other issue or simplification we can make. This 4 is 2 squared. So if we rewrite that, then we can bring the 2 down in front. So we have 2 natural log of 2 times t squared. And what that buys for us is now we can say this 10 divided by 2 will just give us 5. So our final simplification will look like 5 times 1 minus the natural log of t all over t squared times the natural log of 2.